Hello. Hi all. Yeah, let me see the next video. In this video, I'm going to discuss PCA enumeration. Uh, Before going to discuss enumeration, previous videos I discussed what is meaning of PCIe, what is meaning of protocols, types of protocols, and layers, and each layer significant, some packet formation rules, some concepts behind that. What you call uh, lane detection, everything as we discussed. Now we will see the enumeration. What actually enumeration, why it's needed, what is the major significant for the enumeration, why it's came into picture. Let us take as one example. You have a laptop. You want in practical example, you have a laptop. You want to connect any hard disk or any USB port, USB or any memory controller you want to connect, but how it's knowing whether once you start connected, let's take as a 1 TB hard disk you connected in your laptop. Once you start connected in your hard disk, you will see as a what is the total area of the hard disk, what is the available area, what are the files is present in the hard disk. So everything you got to know like in this PC. So how it's knowing, based on that available area only you can able to send the data and you can able to read the data. So you should know the device behavior, like what is the device behavior, what is the address mapping, everything you got to know that hard disk. So these specifications you got to know by happening through enumeration only. This process we call as actually enumeration. The simple definition of enumeration means the process of detecting device connected to the host through PCI controller. This we call as a PCI enumeration. Generally, there is only one host that is connected to the CPU, and which is further connected to PCI switch for connection of more number of devices to connect the different endpoints of the host, showing in this image. Here is a four devices connected to the this host. Host means processor. So once first step will be the reset any of the device. It need to be do the as a first step is a reset. You have a one PCI controller, you have another PCI controller. This controller is connected through lane. Assume as a, this is one is RC, this one is a EP endpoint, this one is a RC direct. You don't need to assume as of now switch is present in between. Switch is not there. So once RC is connected to EP, this we called as a once reset is done, physical layer will do as a link training. This we call as a link. I already told you. This is a link training will happen. Once reset is happen, next will be the connection will happen to one device to another device. This we call as a link training. Once link training is done, that file layer till to data link training is completed. So data link layer will do as a some initialization process signed on. This will do some initialization both side RC and DP. Initialization process will do. Once the initialization will done, the TL layer will start the enumeration process. So this is the way happen in practically. Once initialization is done, it will in enumeration what happen, everything it's coming from the bus device function model. So maximum bus, what is the use of what is meaning of bus? Bus is kind of it's connection. This is a connection, this is one connection, this is a connection. Before going to connect one before going to PCI world, it will connect with the bus model. So every connection we called as a bus. Once bus model is connection is happen, it will do as a bus function model. Bus device and function. This is the way inversion process is going to happen. Once it will connect the bus, then how many devices connected to that bus, and each device how many functions we have. So in this way we will see the enumeration process. So as we go forward you will understand the what is the use of assigning bus numbers, what is the use of assigning devices, how to detect the how many functions is present, how to detect everything. As we go forward you will understand. As of now understand how bus function model will how assign bus number. That is the main point here. In this slide, most important point is how to assign the bus number. Whether here is connected as a bus number 1, here is bus number 3, here is bus number 9. How it's happening. So this is the main motto of this slide. So initially we assume as a host process will give us a this bus number as a 0. This is a common bus connected to two bridges. This is a host bridge. This bridge is connected to two another bridges. This common bus we call as a bus number 0. So once here we in a host bridge we have a secondary and subordinate. These two are the different parameters. Secondary bus number will be the what is the minimum bus number, what is the maximum bus number here. Minimum bus number will be the 0. Maximum number bus will be the initial will be the 255. How 255 I will explain later. But assume as a initial bus number is 0, final bus number is 255. Host will assign like minimum and maximum. In this limit only, it will be the bus number will be the present. And end up total topology. This is a we call as a topology. In this topology, minimum will be the 0, maximum will be the 255. Here is a bus 0 is connected. Then after it will read the data, this processor, whether it will whether it is getting as a proper id or not. Every device will have a own specific id. That specific id are you able to retrieving properly or not. If it is retrieving, that will be the function device also present and function also present. If not, it that will also consider as a another bridge. So in this way, what happen? Once you start from the host bridge, it will see the whether it is bridge or devices. Whether it is bridge, it will assign to the one more bus number. Again, if you see the whether it is bridge or devices. If it is bridge, it will assign one more bus number. Once again, it will go some more depth. These all controlled by software. Software will take care of all these operations. It will search depth in uh, depth to search will be present here. So the concept behind that, it will go up to maximum depth. It will go. Software will take care first. How much depth will be there. So whether it will be connected point is whether it is a device or whether it is bridge. If it is bridge, it will assign the bus number. If it is a device is connected, you got an like any uh, specific ID, that is the actual correct ID, then it will tell us this is a device. Every device it's have a own ID. Let us this ID number is a 1. Whenever it's read ID number is 1 is a correct number, that host will tell to this is a end of the device is present. So these are the bridges. So whenever bridge comes, it will assign the bus number. When device comes, it will assign the device number. If it is device ID is correct, it will assign the device number. In this device, it will have a maximum be 8 functions. Every device, let us take as a USB or any hard disk. Let us assume one hard disk will have a 32-bit addressing mapping. One hard disk will have a 64-bit addressing mapping. Any USB module may be connected in the endpoint. So these are the different functionality we can use to connect the through that PCI Express. So maximum you can for every device you can able to connect maximum 8 functions. So here concept is very simple. Once you are sending a bus number, whether it is bridge or whether it is in devices, you need to identify first depth in search. This is the depth in search. Up to maximum depth you should go. So if you get any devices IDs while reading, if you get any exact ID, if you get into host will got to like that particular point, his device is connected, that device number is 0. So up to how for every bridge, how many devices you can able to connect means up to 32 devices you can able to connect maximum. So Once device is detected, so the host will assign that device number. That device number will inside we have a function. We have a single function, maybe multiple functions. Single function means it's kind of only memory that will have a 32-byte addressing mode. So that is a one function. So same kind of any USB driver, any one function, or else you can implement multiple functions as well in in particular for every devices. So bus number will assign software. Once device is detected, it will device number, how many functions is implemented in this device. So this process we call as a enumeration. So using bus function model, this we called as a enumeration process. Once bus number is everything is done, it will start with a configuration. In the enumeration itself, it's go with the configuration that we called as a process of identifying the device behavior. Like what is let us say you have a function, that function having a space as a 256 megabytes per data, megabytes space will be there. How it's knowing this space, this much space is present in this host, by using as a configuration. So in this configuration, read and write will happen. Based on that read and write configuration, that host got to know, like this is the endpoint, we have a this much area, this much space is present, we can able to access that space to do the some operation. So in this way we will detect the endpoint of the devices. So in next video I will explain the how configuration happen, configuration read and write in the PCI Express. In the overall this slide, what I want to conclusion, the enumeration happen using a bus function, bus device functions. How many? I already told what is the maximum bus you can able to achieve. 255, 0 to 255. So 256 devices are 32, functions are 8. So 256 combination means 8 8 bits is required. For 5 means 5. 32 means 5 is required. 8 functions means 3 bits is required. So overall we need a 18, 13, 16 bits is required for in the packet. So as we go forward you will understand, but maximum you can able to achieve is a here will be the 8 bus number is 8 bits, device number is 5 bits, function number is 3 bits. This is I want to convey in this video. If any question, please let me know. Thank you.